going over the Module 7 test review. Number 1 says, consider the expression below. What is another way to write this value? Choose all that are correct. All right, so first we need to remember our formula, which says that we can convert exponents to radicals and radicals to exponents. So we're going to write it down over here so that way we can see the conversion. All right, and I'm going to start off by converting this one. They already gave it to me as a radical, so I'm just going to work backwards. 43 is my base. Remember, your root is your denominator, and your exponent is your numerator. Okay, so I'm looking for anything equivalent to 43 to the power 4 over 3. Let's start with this one. Now, here I have a power to a power. That means I multiply. So I can put this over 1, and now I can just multiply across. So I have 43. 4 times 1 is 4. 3 times 1 is 3. And that one works. Now, this is a negative, so this is not going to work. Let's try the same thing with this one. So we've got 43. We can put this over 1, and it's a power to a power, so we just multiply 3 over 4. Now, 3 over 4 and 4 over 3 are not the same thing. Next, we have, again, this is just going to be 43 to the negative 4 power times 3, and it's not even close. We've got 43, 3 to the 4th. Again, 3 to the 4th and 4 over 3 is not the same thing. And 43 to the 4 over 3 power, well, that one matches. Number 2. Look at this expression, which is an equivalent expression. Okay, so don't let all the fractions confuse you. Let's try it with a simpler version of this and see what we're doing. So let's say we had an example like this. This makes it easier to see what properties we're going to be following, what rules we're going to be following. Well, I know if they have the same base, I would add the exponents. So I'm going to start by doing that. I'm going to take these two fractions and I'm going to add them together. Now, in order to add a fraction, they have to have the same denominator. So I can modify this and I can just multiply with each other. So I'm going to start by multiplying this 5. Whatever I do to the denominator, I must do to the numerator. So I get 10 over 15. And I'm going to do the same thing on the other side. Plus 6 over 15. And that's going to leave me with 16 over 15. Now from there, I get a power to a power. I'm going to multiply it. So I'm going to do 16 over 15 times 1 over 2. And that's going to get me 16 over 30. Okay, 16 over 30 can be simplified. They're both even numbers, so I can divide by 2. That's going to get me 8 over 15. So my final answer is going to be x to the 8 over 15 power, and that is B. Okay, number 3. Pat simplified the expression in 3 steps as shown. Step 1, step 2, step 3. Are there any errors in the simplification? And if so, in which step does the error occur? So let's start by taking a look at what Pat did. So we want to know, how did Pat go from here to here and so forth? So we can tell that the first thing we should have done is, when we are dividing and we have the same thing on the top and the bottom, we're going to be subtracting. So I know we could have done 5 2's on top, 1 2, 4 on the bottom, 1 2 3 4. You cancel out when you have the same thing on the bottom, on the top and bottom. So we're left with 5 to the second on the bottom. So that seems to be right. Now let's check the 2's. 1 2 4 5 6 7 8 9 10 over 1 2 3 4. So cancel, 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 cancel. We should have 1 2 3 4 5 6 2's on the top. Well, we don't have 6 2's on the top. We have 14. It looks like Pat added the 2 rather than subtracting. So her mistake was right off the bat in step 1. Okay, number 4. Number 4 says simplify the expression. Okay, so we've got z to the second to the negative 9th power over z to the negative 8th. Okay, well, let's start with power to power. I know if I have a power to a power, I multiply. So I'm going to do z, 2 times negative 9 is negative 18 over z to the negative 8. Now, I can't have negative exponents, so that's going to cause me to flip it to the other side. Now, because they're both negative, they are both going to go to the opposite side. So this would become z to the 8th over z to the 18th. And now, anytime I have the same thing on the top and the bottom, I can subtract. 8 minus 18 is going to give me z to the 10th on the bottom. Now, I don't have a problem that looks like this. So I have to try a different method. Now, I also know that 8 minus 18 is z to the negative 10th. And I know that z to the negative 10th is the same thing as 1 over z to the 10th. So that's going to be C. Number 5 says, which of the following equations are true? All right, so we're going to go in and we're going to individually check each one, see if it's true. So here, let's start with this a to the negative 2. I cannot have a negative exponent. So this has to be moved to the top. All right, now I can simplify. I've got 2 plus 5 more a's, a to the 7th. If I have the same thing on the top and the bottom, they cancel out. I'm left with a to the 7th. So A is a possible answer. B, before we can start simplifying, we have to distribute this power of 2 to everything on the inside. And remember, anytime you have a power to a power, you multiply, and if there's no exponent, it's automatically raised to the first. So this is x to the 2nd, y to the 6th, over x, y to the 2nd. And we can start canceling out. I have 2 x's on top, 1 on the bottom. That leaves me with just 1 on top. I have 6 y's on the top, 2 on the bottom. That's going to leave me with 4 on the bottom. And that's going to be, oh, that's true. So A and B are possible answers so far. Let's try C. So for C, we have to start by distributing as well. So we've got c to the negative 4th, d to the 2nd, over cd squared. Okay, well, I know I can't have a negative, so this is going down to the bottom. So we've got c to the 4th, this is gone. I'm left with d to the 2nd. I've got 5 c's, and 2 d's on the bottom. 2 d's cancel out. Can't have nothing on top, so I'm left with 1 c to the 5th, which is also correct. Okay, let's try D. So here we've got a negative, need to move it to the bottom, and another negative, need to move it to the top. After we do that, we've got 2 plus 3 more, b to the 5th, over 8 to the 4th. Oh, this does not look like it is a match. And finally, letter E. Again, we have to distribute power to a power. We get a to the 8th, b to the 12th, over ab squared. And again, we subtract 8 on top, 1 on the bottom. I'm left with 7 on the top, and b to the 10th, and also does not match. So our answers are A, B, and C. All right, let's go to number 6. Okay, number 6 says, which is equivalent to 3 square root of 20 divided by 2 square root of 4. All right, so let's start by, well, I already know the square root of 4. We know the square root of 4 is 2, so I can actually already do the bottom. I can do 2 times 2, because the square root of 2 is 2, and when two things are right next to each other, we're multiplying. I know 2 times 2 is 4. Now, even though I see this here, I want to hold off because I don't know if I can simplify any further. I want to figure out the top before I simplify. So I do not know the square root of 20. So I'm going to use the factor tree to find, to simplify the square root of 20. Well, two numbers that multiply get me to 20 are 5 and 4. We can break up 4 into 2 and 2. And that's it. So now I need, my index is 2, so I need 2 of the same number. Well, I've got 2 2's, so that's going to go on the outside. And I've got my 5 left on the inside. And I bring back my original 3 that was on the outside. So that leaves us with 3 times 2 is 6, square root of 5. And I can put that on the top. Now, you've got to be careful because if you would have chosen this answer just because the 4 was on the bottom, you would have gotten it wrong. Now, I don't see this answer here. Well, that's because I can simplify 6 over 4. 6 square root of 5 over 4 can be simplified. I can simplify 6 over 4 because they're both multiples of 2. Or they're both divisible by 2. So I can divide both 6 by 2, which gives me 3 square root of 5. And 4 divided by 2 is 2. And that's going to leave me with C. Okay, number 7 is to simplify the expression. Now, in order to add or subtract radicals, the index has to be the same, which in this case, they're both 2, so we're okay. But the radicand also has to be the same, and they are not. So I'm going to start by simplifying. Let's start with the 54. Two numbers that multiply to 54 are 9 and 6. I can break 9 down into 3 and 3, and 3 and 2. I need 2 of the same number to form a group, so I've got 2 3s. That's going to put 1 3 on the outside. And 2 times 6, or 2 times 3 is going to be left on the inside, which is 6. And I want to make sure I bring down this 3. So I've got 9 square root of 6. Well, that still doesn't match my 24 here, so that means we've got to simplify our 24. We can do 4 and 6, 2 and 2, and 3 and 2. We need groups of 2, so we put our 2 on the outside times our negative 2 from up top, and we're left with 2 times 3 on the inside, which is now 6. So I can bring this down. I've got 6, negative 2 times 2 is negative 4. All right, and once my radicands are the same, now that they're both 6 and 6, I can just do whatever operations my outside numbers are. Well, negative 4 plus 9 is 5. So I get 5 square root of 6, which is A. All right, and finally, we've got simplify the expression. The square root of 6 times the square root of 3 times the square root of 5. So in this case, we can just multiply. I know 3 times 5 is 15. Times 6 is going to give me 90. So we're simplifying the square root of 90. Well, that's not an answer choice, so I'm going to do my factor tree. I can do 9 and 10, 5 and 2, and 3 and 3. So remember, my index is 2. I need 2 of the same numbers. Well, I've got 3 and 3, so that's going to go on the outside. And I'm left with 5 times 2 on the inside, which gives me 3 square root of 10. And that is going to be A. And that is all for our Module 7 test review.